Hey everyone, I'm Patrick Jones, and welcome to episode 77 of That Gives Me Anxiety. God, I gotta tell you, if you haven't read Elton John's autobiography called Me, oof, it has nothing to do with anxiety. I mean, oh well, it does, right? He talks about his mental health and struggles with drugs and alcohol, which is certainly on board. So I don't know what I was getting at there. I apologize. Mistake right off the intro. But yeah, I'm really enjoying it, man. It just the ability to be so honest and share stories, some of which are extremely embarrassing for him. But it's also like he wrote your song. So can it ever be that bad? Can he ever really be that embarrassed? He's not playing on the same field as we are. Unless Dave Grohl's listening, because then he is. Well, this week I just want to jump right into the interview. I broke it up into two parts. It's one interview with Mr. Charles Liu from the American Museum of Natural History and City University of New York, CUNY. Sometimes I struggle saying that, especially on the spot, right? I like these intros to have a conversational feel to them. And there will be speaking errors occasionally, not on purpose, but CUNY, New York. City University of New York, Staten Island, was more than generous with his time, where we talked about black holes. And there was so much good information that, yeah, like I said, I had to split it into two so you could savor it, right? If you eat the way I eat, it just goes down fast and then you regret it. This is like wine tasting, talking to Charles. He has such a enthusiasm for what he does, and he's able to explain really complicated stuff in ways that we can understand, which is, I mean, what a gift for someone in his position, and what a gift to us that someone in his position takes the time to do this. So it's just thrilling and it's exciting to have Charles, and I know you're going to love these two episodes. As I mentioned, it's on black holes. This episode, the questions are more in line with how we figured out that black holes exist, which is a crazy story to begin with. And then the next episode talks more about the ins and outs of what's going on with black holes. But before we get to the interview, I just want to remind you, if you're liking the show, to please remember to rate and review it 5 stars. Wow, what a great interview with Charles. You can check the show out on Facebook, Instagram, Twitter, and YouTube, or YouTube. On YouTube, you can see how tired I look from wedding planning. Doing this super late at night. Normally I don't do it this late. Hey Pat, is that why you cut down on the intro a little bit? Maybe. Also, my partnership with Pure Spectrum CBD. Don't forget the promo code ANXIETYPOD, one word, for 15% off your order. And if you're liking the show and you want to support it by making a donation or a tip, you can do that with the link in the description for the Buy Me a Coffee link. I'm just saying link too many times. Conversational. Well, I know that this is going to be a lot of fun, and I really hope you enjoy this. So, yeah, thank you so much to Charles, and enjoy part 1 on black holes. Joining me on the podcast once again, I have the pleasure of welcoming Mr. Charles Liu from the American Museum of Natural History and the City University of New York. Charles, thank you so much for coming on.
Oh, thank you so much for having me. It's a pleasure to be back.
Yeah. Well, the last time we spoke, we were talking about the end of the universe, but today we're going to be talking about black holes.
Yes, an existentially awesome topic.
It is, yeah.
Yeah.
Before we jump into the science aspect, I'd love to give you a moment to introduce yourself to the listeners.
Oh, sure. Well, I am an astronomy professor at, as you said, at City University of New York at the College of Staten Island. City University of New York is known as CUNY, and It has about 25 campuses, each with about 10,000 students, give or take. And we're on the one on Staten Island, and we have a wide variety of students. So the best ones are as good as any students I've ever taught or been to school with in any universities. And it's a real pleasure to be able to talk to that. I also work at the American Museum of Natural History. We do a lot of research work there and outreach work. We work with students, not just in New York City, but all around the country, in trying to do authentic research experiences where they can learn how to become a scientist and just to start meeting the people that they will wind up being colleagues with not too many years in the future. So it's a real pleasure, and I really have a lot of fun with it.
Yeah, that's great. I mean, it must be so fun watching the excitement of a child getting some research opportunities at the American Museum of Natural History, right? It's such a step outside of their box, right? And
That's
it must be
right.
so
That
fun.
really is. I mean, these, I would hesitate to call myself when I was in college a child, but really, looking back, I really was. And
That's
what it
just being
is
honest. Yeah.
it's a good kind of child, right?
Yeah.
Because you have the power of an adult, but you have the wide-eyed curiosity and the sort of absorption level of a little kid.
Hmm.
And you're in a university very often, you have students that, just thinking about classes, thinking about exams, thinking about, professors and whatnot. And then you come to the museum to do research, and there are 5,000 little ankle biters running all around, pressing all the buttons and pounding on things and
Yeah.
trying to sort of learn about neat things in the universe in a whole different way. Right. And that's
Yeah.
really what we want to do. We want people to realize that being good at science, or really at anything, right, isn't just about getting good grades or being able to memorize individual facts or regurgitate formulas or anything like that. It's about looking at the world and poking and prodding at it and saying, I wonder what the deal is here, and then bringing to
Mm.
bear all your knowledge that you've learned in school to solving those mysteries. That's the fun part of science, and not enough people get a chance to experience that firsthand.
Right. It's like, true crime is so popular because people can start to piece things together. But isn't that just what science is? Except,
Pretty much.
yeah.
Yeah, yeah, exactly. And it's
Yeah.
so, I mean, true crime is kind of fun, but I feel like I have even truer crime that I can share with the world. And the crime is like, why did my thing fall from the sky? Or,
Yeah.
why did the sun do that yesterday? Or, it's really a kind of a fun way to think about it. Why
Yeah.
does the universe do its thing? And I
Yeah.
really enjoy it.
Can we talk? I know you've got a lot on your plate. You've got work, you've got friends, you've got family, pets, you've got the people that you make small talk with at the coffee shop or gym. You've got that bird that you see when you wake up every morning outside your window that you've projected things onto. Look at that bird. Doesn't even love its family, it's always by itself. You do that. Everyone does that. Point is, you've got a lot on your plate. Well, that's why there's Instacart, to take a little bit off your plate. Using Instacart, you search for all your favorite foods and things that you need from the grocery store, all online, all while you're looking at that bird, wondering why it hasn't called its mom. And they deliver it to you. They go to the store and do the shopping for you. And they can deliver it in as fast as an hour. And you can sign up by clicking the link in the description, wherever you're listening or watching. And that's a great way of supporting the show. So it's a great way of supporting this show. It's a great way to make your life a little bit easier, because we all know that you have so much going on, like wondering whether that bird judges you back. Well, jumping into black holes here,
Sure.
correct me if I'm wrong. We first learned, we as a species learned of
Yes.
black holes from Albert Einstein's theory of general relativity. It was a byproduct of that formula. I mean, first off, is that the case? And secondly, it's like, so you're seeing these numbers, he's seeing these numbers on and is able to derive that story of a black hole. I don't even have a question for you there, Charles. That is just so mind-blowing to see numbers and be like, well, that means this.
Right. Einstein was indeed that kind of visionary. He has a lot of quotes out
Mm-hmm.
in the history of science. One of the quotes that I liked the most was something that he published in 1930, first in German, then in English in the New York Times. It was translated into English as "What I Believe." So it was like an essay, it was sort of almost metaphysical in a sense, but truly talking about what does it mean to be a scientist and what science is all about. And
Mm-hmm.
what he basically said, the thing that ties together all great art and science is the sense of being awed by the mystery of the universe. If you
Mm-hmm.
can just feel, wow, that is so cool, and just think beyond what is just there to be tangible, then that's really the root of creation that humans have been able to tap into for all civilization. So, what Albert did in this instance was he imagined that space and time were tied together in a sort of a four-dimensional fabric, and it's been nicknamed space-time, and
Mm-hmm.
the name is stuck, right?
Yeah.
And so, in order for that knitting to happen, he basically tied together systems of complex mathematical equations, things that you might use, for example, if you're computing the twisting of cables in a suspension bridge,
Okay.
or if you're computing the compression of some sort of large machine or the piers of a huge building or something like that, and said, well, what happens if instead of thinking about objects, concrete or metal or whatever, we thought about space as being able to be twisted and bent like that? It was amazing. It was quite the insight, but experiments showed that he was correct. And so then the search went on, right? Because once you get the mathematical structure down in physics, the next thing to do is to say, okay, mathematical structures give us nearly infinite possibilities, but
Mm-hmm.
we live in one universe.
Mm-hmm.
Therefore, which amongst all those many, many possibilities is the correct possibility,
Oh my
right?
gosh.
So you have to take these very complicated solutions, right? We call them
Uh-huh.
the Einstein equation, and then you chip away at them. You say, well, that's not possible, or that's not true, or say, oh, well, space and time are like this, so those possibilities aren't the case. And so slowly but surely, you're isolating down into solutions of the equations that reflect reality.
Just like looking for your car keys, right?
Pretty
Just
much in the
yeah.
snow. Yeah.
Yeah.
It you got to keep scraping slowly, slowly,
Yeah.
slowly till you find, the actual ground truth. And so one of the solutions of these equations was a very strange one that did not reflect reality at the time.
Hmm.
It basically said, well, if space-time is indeed in this four-dimensional structure, then there can exist in space-time things that don't follow the rules. In
Mm-hmm.
other words, little patches of space and time that are almost like holes, like they're rips in this fabric of space time, that they're like bulges, things that have been curved in such an extreme way that if an object tries to come out of them, it can't because space has been so pinched off.
Oh my
So,
gosh.
so this is the mathematical basis of the black hole. The
Hmm.
thing is, astronomers had thought of the existence of something like a black hole long before
Oh, I didn't
Einstein
know
showed
that.
that it was
Wow.
mathematically possible. That's right. Because you
Wow.
see, in the olden days, this is, well, I guess in the 1600s and 1700s,
Hmm.
folks like Isaac Newton
Hmm.
had figured out that gravity was a kind of a pulling force,
Right.
right? A force that you could pull things from one part of space to another part of space. And the idea of orbital velocity and escape velocity had been established at that time. So
Hmm.
that meant that, well, if you are on the surface of a planet like Earth or something like that, anytime you wanted to leave the planet, you had to achieve this thing called escape velocity, right? And this is something that we know today in rockets and everything like that all
Hmm.
the time. Think about orbital velocity and escape velocity and things like that. But in the 1600s and 1700s was a newfangled idea because, of course, no one had ever escaped Earth orbit. So
Yeah.
there was nothing there. So scientists, one in particular, a guy named John Michael, who
Hmm.
was very good. He doesn't get a lot of press in public scientific knowledge, but he was a smart guy, and he said, you know what? Could you imagine a planet or a star or an object where the escape velocity was so high that a piece of light couldn't escape. We could shine a flashlight upward and the light would just go flying out through the clouds and everything like that, right? Up into
Hmm.
space. But imagine if I shone a flashlight up and the gravitational pull was so extreme that that piece of light would go up and then fall back down like a baseball that
Oh
was
my
hit off,
gosh.
by a batter. And so he thought already, well, if that were the case, then that object would appear black to us
Hmm.
because the light couldn't get to our eyes, right?
Makes
So
sense.
the idea was thought of already back in the 1700s. And then in the 1800s, there was a guy named Carl Schwarzschild. Okay.
Solid
Um,
name.
yeah,
Yeah.
good, solid name.
Yeah.
And many people consider him one of the first true astrophysicists. You know, someone who took modern physics and applied it to things other than what is on our Earth. And he kind of took that idea about escape velocity and things like that and ran with it.
Hmm.
He imagined that any object, if it had a certain amount of mass and it had a certain radius, a size, you could make a size for any object with any amount of mass such that if that sized object contained the amount of mass,
Mm.
then you indeed would have escape velocity being the speed of light or greater.
Oh my gosh.
So,
So like my body condensed into like an atom or
right,
anything like that.
right,
Anything could
something
be a
like
black hole.
anything could be this black
Wow.
hole. Right.
Wow.
And so that radius was a surprisingly simple equation, which became known as the Schwarzschild radius.
Hmm.
And so what he said was, well, if we ever find something out in the universe that's actually massive enough and small enough, it would look black. And for
Hmm.
all intents and purposes, it would be like a hole in space where you could fall in and then you could never come back out again.
Oh my
And
gosh.
so, so this was a really cool idea. Now, to get some sense of what that is, if you have the entire Earth
Okay.
and you squished it down so that it was the size of this Schwarzschild radius, okay,
Hmm.
it'd be about the size of half a golf ball.
Oh
So
my gosh.
it'd be like a little like a gumball, you know, like a big gumball. So a little bit smaller than a golf ball would basically, if you contained all of Earth's mass into there, then light could not escape from that gumball-sized object.
Oh my
So it's a pretty amazing tiny small. As you get more massive, though, these objects become larger. So if you take the sun, which you know is more than 300,000 times the mass of the Earth,
gosh. Hmm.
then the Schwarzschild radius would be a few miles.
Hmm.
So it's starting to get something you maybe could stand on, right?
Yeah.
Yeah. And if you took, say, 100 million suns
Okay.
and put them all together, then the Schwarzschild radius would be a fair fraction of our solar system.
Oh wow.
You know, so you could start seeing like objects out there. They'd have to be super massive, right? Things that we couldn't understand at all, but they could exist out in the universe. And it could be reasonably true that such objects existed. So then, when Einstein's equations came out, people worked the calculations, and lo and behold, they were able to derive the Schwarzschild radius from Einstein's equations that said, you know what, folks, black holes should exist. They should be
Wow.
out there. This is not just a theoretical construct, guys. We should be able to find them. Now the question is how? Because they're black and they're
Yeah.
holes. We can't exactly send a space probe out there, look to find some bright object and call it a black hole, right? So it becomes really hard. We we almost have to look for black holes the same way like on a pitch black night we look for
Mm-hmm.
cars, right? We cannot see the cars because it's absolutely dark. But if we see a pair of headlights, then we think, ah, maybe there's a car behind it, right? And
Okay.
that's what we had to do. We had to find the cosmic equivalent of black hole headlights and to see if they existed. And
Yeah.
it wasn't until our lifetimes, really, that that kind of confirmation finally happened.
Oh my goodness. One of life's mysteries is that birthdays always find me unprepared, catch me unprepared. I don't go on Facebook as much, so I don't notice them as much. But I want to express my love and appreciation for friends and family. That wasn't part of the copy. I'm just saying it. Year after year, month after month. Even when I see it coming, I'm not ready. Am I a jerk? Yes and no. Why do things have to be so black and white for you? But I've got great news, friends. Introducing monthly card subscriptions from the Cardist Studio. Join the service that delivers the card and the stamp that you'll need to your door. No more errands. Who wants more errands? I don't know why, but I'm starting to think of errands as a kid's name. Errands, go back to bed. Okay, but here's how it works. You choose your categories, from birthdays and celebrations to love and encouragement, or select their full collections and have those thank you notes and just because cards at the ready. Those ones are always so nice. Like when you get a card for doing something and it's just like a small little heads up or token of appreciation, it genuinely makes you feel really good. And best of all, you would never get caught cardless again. Let me repeat, you'll never get caught cardless again. Try to say that a bunch of times in a row. You'll never get caught cardless again. Monthly card subscriptions from as little as $8 per month for the card and the stamp. Delivered to you. TheCardistStudio.com shop subscriptions. And you can use the promo code AnxietyPod for 15% off your originating order. And what around like what year was that? Like
Well, the
70s or so?
first really good evidence that black holes existed
Uh-huh.
probably came out in the 1970s.
Wow.
Okay, what happened was that a new generation of telescopes in space came out during that time that were
Mm.
sensitive to X-ray emissions.
Mm.
All right, so you have to have something very powerful, very energetic, maybe something that's got a temperature of millions of degrees. Okay, so imagine taking the center of the sun and smearing it out, all the way out to the surface of an
Mm-hmm.
object like a sun.
Mm-hmm.
Then all that nuclear fusion in the middle of the sun, that's millions of degrees, gamma rays, X-rays, all that sort of stuff, would then be visible to us. Right.
Okay.
Our sun, because it's almost a million miles across, right? By the time the nuclear fusion, the very energetic activity in the center, all that energy diffuses out through the sun. It's this gentle, yellowish, greenish light that comes to
We
us and
just get
warms us.
tan and
Yeah,
yeah.
that's right. So that's what happens. But can we see something so bare, like a core of something that could emit X-rays like that? And so these new X-ray telescopes from the 60s and 70s indeed found some kinds of strange objects. They looked like stars. They seemed to be maybe stars, but you couldn't see them. All you could see were their X-rays. And you're like, that's funny. Where are these objects that are so powerful yet so small? Eventually, some of these objects were found completely indirectly. They found the headlights. What
Oh
happened
man.
was that, I'll use a specific example. There was one of the sources, it was in the constellation Cygnus. So you look toward the constellation Cygnus, the Swan, and it was the brightest X-ray source in that part of the sky. So it was known as Cygnus X1.
Mm.
Astronomers looked carefully in the area where they thought Cygnus X1 was. They didn't find Cygnus X1 at all. But what they did find was a star that was wobbling in a very strange orbit. It looked
Mm.
like it was going around nothing.
Hmm.
But this star was going around, and the nothing was a really bright X-ray source. But
Oh
they couldn't
man.
see a star. And so after doing some calculations, they came to the conclusion that, wow, in order for this invisible object to produce so many X-rays and to be able to affect the orbit of this other star so vigorously, the
Mm-hmm.
object had to be smaller than the Schwarzschild radius
Oh
of
wow.
another star. And so this thing became the best evidence for a regular black hole. Well, we call them stellar black holes. They're still super awesome, but they're not super massive, right?
Yeah.
And so this was getting pretty close. All right.
Yeah.
This was at this point was around the time that Stephen Hawking, of blessed memory, the famous physicist, made a bet with another famous physicist, a guy named Kip Thorne.
Mm. Another great name. Look at these
Another
physicists with
great
great.
name.
Yeah,
Yeah.
that's
Um,
awesome.
yeah. Well, this is part of the fun of physics, right? A lot of us we sort of envision physicists as sort of soulless, humorless individuals that stare at their equations all day long. No, not at all. Just like Einstein said, right? We're just as childlike and awed by mystery as
Exactly.
anybody else. And
Yeah.
so Kip Thorne and Stephen Hawking were talking black holes one day, and they said, should they exist? Well, they should, but how come we haven't been able to find them? Whatever, that kind of thing. And so they made a friendly bet. And they
Hmm.
said that, well, in our lifetimes, will it be confirmed without beyond a reasonable scientific doubt that black holes actually exist? And so Kip Thorne bet that yes, it would. And then Stephen Hawking bet no, it would not.
Not what I would have guessed, right?
Right.
The one man whose name I knew, and there was a movie made about him, was on the
That's
wrong
right.
side there.
Well, Hawking took the other side of the bet, he said, not because he didn't think it would happen,
Okay.
but that he said that if it didn't happen, at least he would have the satisfaction of having won the bet. And so he took the other side of the bet, and in a famous sort of picture, which I think is around on the internet, there is a line underneath this bet, which is written on the corner of a chalkboard in Kip Thorne's office, and it says conceded. And it shows Stephen Hawking's thumbprint in chalk, saying, yes, indeed, we now know that it exists. Because
Wow.
the supermassive black holes were
Hmm.
absolutely confirmed to exist thanks to the Hubble Space Telescope and a number of other interesting technologies.
Wow. Man, this is all. I'm just like sitting here with a giant smirk on my face. It's just so mind blowing. Uh, the something that seems like it's from a Marvel comic
Yep.
is out
Yep.
there in the universe.
Isn't it
It's
neat?
just,
Yeah.
yeah.
They are pretty amazing things. And yet, one thing that I think a lot of people don't appreciate is how actually normal they could be if
Hmm.
only we could figure out what's inside them. Remember, we can't get radio signals out, so we can't send a probe in and then find out what comes out, right?
Hmm.
We can't know what's inside. It could be a whole different set of laws of physics inside a black hole, and we wouldn't know. Or there could be 10 million pink elephants dancing, saying, yeah, you can't see us. We don't know, right? So
Yeah.
that's the cool part about it. But these supermassive black holes, if you do the calculations, it turns out that if you have a black hole, let's say 1 billion times the mass of the sun, okay, and
Hmm.
such black holes do exist,
Hmm.
the overall average density of that black hole is less than that of water.
Oh, wow.
Yeah. So it's really kind of interesting. If
That
you could
is.
somehow assemble 100 million or 1 billion suns worth of water, you'd wind up with a supermassive black hole. And water's a perfectly ordinary, normal thing,
Yeah.
right? So it's not at all that exotic the bigger you get. So the question simply becomes, how do you build them? And once you get them that big, right, do things normalize inside, right? Is
Mm.
it actually something reasonable? Or is it still this completely unfathomable kind of material, which we could never see here in our non-black hole environment?
Wow. So yeah, part one on black holes. Make sure you come back next week for part two. Thank you so much to Charles, and who has a podcast which he goes into more detail in the second episode, the Luniverse, Liu Nerverse. Before I get to the weird thing causing me anxiety this week, I just want to remind you of the Buy Me a Coffee link. It's in the description, and it's a way to make a donation to the show. The Pure Spectrum CBD. Don't forget the promo code AnxietyPod for 15% off your order. Instacart, if you want to sign up for home delivery for groceries, you can click the link in the description, and that will tell Instacart that this show sent you, which also helps support the show. And then the Carta Studio also offers the promo code AnxietyPod for 15% off your order. So, all right, the weird thing caused me anxiety this week. Having a bit of a stressful couple weeks, right? We're planning weddings, and there's just a lot that goes into that, right? But when your cup is full, even like a few more drops can really send the anxiety off the charts. So we live in a 4-bedroom house. There's 2 of us here, plus Ollie the pup. And I noticed some dirt in a corner, and like, where the wall meets the roof, like that, like triangle corner. There was like a little bit of dirt in there, a little like spider web in one of the rooms. And my anxiety went to the moon. We were just like, oh my God, there's a spider web in there. We're trash people. Just completely beating myself up. It's not like we live in the house that the Munsters lived in. We're just tired and focused on other things, right? We still also have jobs. And so, yeah, I'm much nicer reliving these events than I was at the time of just coming down hard. There's a spider web. Also, we live in South Carolina. There could not be more spiders. Which is good because there's a lot of mosquitoes, right? So yeah, I gotta figure out how to be nicer to myself and just not go off the deep end because I saw a spider web in the upper corner of a room that we don't use as much. Yeah, deep breathe. Well, as always, thank you so much for listening, and make sure you come back next week for part 2 on black holes.